Hello, this is Patrick Fleming, and I will be presenting Lab 5, which is the Choose Your Own Adventure Lab for Physics 1 at Georgia Tech. So this lab will be an expansion of Lab 2, and I will be dropping a Tervis water bottle and a piece of paper, and using the tracker model, I will put the values into VIDLE and predict how far apart these two objects would be after dropping for 5 seconds. So how we're going to do this is the three formulas that we learned in physics. So the first one is the kinematics equation. So this equation will be helpful for finding the final position after a certain amount of time. Newton's second law will be helpful for finding the final velocity after a certain amount of time. And the turbulent velocity will be helpful finding the velocity with a certain wind resistance of the object. This wind resistance is what will make the water bottle travel faster than the piece of paper in the observations. So we modeled this in Tracker, having the video horizontal so we can track it on the x-axis. And here we can see how the water bottle goes much faster than the piece of paper when dropped, and we will find out why when we put it into our VIDLE. This is the data. You can see that the water bottle equals a much further distance in much less time. So what I had to change from Lab 2 was the code so I could model two objects right next to each other that had different B values in the same while loop. So how I did this was I separated the work and force done on each, and I had the velocities and positions different. And I created a new object, 1 unit to the right of our original object, and this would model the piece of paper. So now we'll see the model of our 5-second prediction and how far the bottle will be from the piece of paper after 5 seconds. So here we can see the bottle is the blue ball and the piece of paper is the green ball. They're going to go out of the window because 5 seconds is a long period of time, but we do have the graphs on the right that will still show us the distance. So this will travel for 5 seconds. You can see the piece of paper flattens out very quickly because the high B value, while the water bottle continues to accelerate faster despite the time growing. So after the 5 seconds, we can see the water bottle is around 117 meters from where it started, and the piece of paper is around 22 meters from where it started. So we found the B values using that VIDLE program based on the tracker data we found from the video that I took. So the water bottle's B is 0.0015 and the paper's B is 0.0025. So the question I want to ask is, does this make sense? So we'll go back to the formulas that we had earlier. The turbulent velocity being negative B to the velocity squared, v hat, which is the direction of the velocity. So this would make sense. The paper has a larger B, so the velocity would not be as high. And the next question that I pose is, what would make an even larger B value? So we would need something with more wind resistance or air resistance, so maybe a parachute or a larger piece of paper. would make a larger B value and an object that moves even slower while free falling from gravitational force. So thank you for watching my video. I hope it was interesting.